Continuing to look at the taxonomy of AI risks, AI race is actually happening between the countries, corporations everywhere, pushing nations and corporations to rush on AI development. Meaning, you would see, right, every day some organization is releasing a foundational model on large models. Cyber warfare, autonomous weapons, automate human labor may all, at least there is, some people believe that it will all increase the unemployment and dependence on AI systems will increase. Military, right? Military is also becoming, we'll see later in this deck also, there is weaponization of AI is becoming more and more critical, and more solutions are being built which can be used for wars between nations. Low-cost automated weapons such as drone swarms outfitted with explosives could autonomously hunt human targets with high precision, performing lethal operations for both militaries and terrorist groups, and lowering the barriers of large-scale violence. Interesting to think about, right? Where you feel that somebody sitting in very safe zone is able to actually do a attack or get a drone onto a place and drop a bomb. Earlier, when people had to go for war, people who were defending there is actually killing others or shooting people or dropping a bomb, doing all that. So that is sort of say a war zone in some sense. Whereas today, if somebody had to do a bomb to a location, they're just sitting somewhere in a safe place, sending a drone with a bomb, dropping it and killing people. It's also asymmetry, I guess. There's no people in earlier days. People were fighting to each other, and I'm generally somebody who's going to kill others in a war is because if I don't kill, I'm going to get killed. Whereas in this case, sitting in a safe zone, I'm just throwing a bomb, right? So me in a safe zone, whereas people I'm killing are in the unsafe zone. The corporate, of course, just now I said corporate and countries also. Models are being built, and then automation of many of these tasks are increasing. Economy will become largely run by AIs, right? Companies which have stronger AI technology, stronger AI models are going to probably run the business. Eventually, this could lead to human enfeeblement and dependence on AIs for basic needs. This is basically saying that humans will become weak. Right? Humans will become weak, and there'll be a lot of dependence on these AI technologies. What are some solutions? Please treat these solutions are also slightly at an abstract level. Safe regulation, self-regulation of companies. There's an idea called SRO, self-regulatory organization, which is you organizations come together and say that, look, these are some things that we will do and we will not do, and actually follow it by every year or at a certain period, disclose that what they did and what they did not do. That will help maintaining the commitment that they had for what they will do and what they will not do. Self-regulations of companies, competitive advantages for safety-oriented companies. Definitely providing incentives for people who are saying that, look, we are building technologies which is also safe. Data documentation, transparency and accountability. We'll see transparency a bit later. Transparency is to say that, look, whatever I'm building, everybody can see how the algorithms are making the choices. Accountability is if something goes wrong, who's accountable. If Tesla cars makes a mistake, who's responsible? The developer, Tesla as a company, all of that. Meaningful human oversight for all the problems, for most of the problems that we are discussing, it may be that human oversight will address the problem. That's the solution here. Anomaly detection we already mentioned. International coordination, I think this is becoming, day by day, this is becoming greater importance, where different countries have to talk to each other, develop models in which how country A is doing AI solutions, how country B is doing. If something has to go between country A and country B, what should be the model? How, I mean, I think this is very, very similar to what had happened before in terms of data, right? At some point in time in India, we were doing business with other countries. Data coming into India had to be actually sanitized, anonymized. All of that was going on. Similarly, now we are talking about standardization of AI development, robust verification enforcement, who's developing, what is being developed, can you have control over what is being developed, all that. Public control of general purpose AI. Of course, the general purpose AI systems that we are using, systems like ChatGPT, all of that, can there be a control of what is to be available for public and what is not to be available for public? Organizational risks, right? Developing advanced AI cause catastrophic accidents, meaning a company is producing something or building some AI solution because of which they could actually have bigger accidents. Profits over safety. Companies are going to look for profits, and if they don't take care of safety as much as they should, then they're going to have after effects for that. AI could be accidentally leaked to public or stolen by malicious actors, or organizations could fail to properly invest in safety research. Meaning, I think these are self-explanatory there. If they don't do safety research, it's going to be hard. We've already seen some examples of where some solutions that were put public, which had an after effect because safety was not taken care of. Again, nothing is new in terms of AI, meaning earlier, probably 50 years or before, when aeroplanes were made, safety measures were so much of discussion, what safety to do. And today, if you see, airplanes are probably one of the safety measures that we have in airplanes are very, very well advanced. I'm sure at some point in time, similar things will happen to AI systems also, AI development systems also. New capabilities can emerge quickly and unpredictably during training, such that dangerous milestones may be crossed without even knowing. Right? So, today, organizations, if you see, they put in a lot of these different steps, stack, where the risks are being mitigated. Right? Safety culture. I mean, if you think about it, organizations, I mean, again, going back to a different context, if you think about sharing passwords, if you think about phishing, if you think about cybersecurity as a problem, safety culture, right? Every month, every quarter, they would have a safety training program. They would have oh, you should not open attachments, you should not do that. So similarly, culture has to be set in terms of doing AI systems, building AI methods. Red teaming is red and blue teaming are the words that they would use, is to actually have a team within the company, have a team within the team of this AI systems, where their goal is to only to break the models that people are building or the teammates are building, so that they would know the limitations of these models. Cyber defense. Develop methods by which these problems occurring in these models can be actually defended. Different methods are available. Can the companies, can the developers deploy these methods? We already talked about anomaly detection, transparency also we spoke about. So if you think about putting all of this together, gives you an understanding of how a company can actually reduce the risks of any after effects of building these AI technologies, AI methods. Swiss cheese model is this idea of at different places you have defense, different layers, so that things don't go through very easily. Shows how technical factors on improving organization safety, multiple layers of defense compensate for each other's individual weaknesses, leading to a low overall level of risks. Right? It may be that there are some drawbacks here, some drawbacks here in all of them, but when you put them all together, they actually become uh, much more stronger in terms of defending the risks. Some solutions, probably building on the last slide itself, red teaming we just saw, prove safety, whatever you're building. Is there a method by which we can say that prove every solutions, prove every algorithms that you're building? Deployment, right? Deploy it so people can actually open source it in some sense. Also, publication reviews, these are sometimes connected. Response plans, if there's again, this is connected to accountability that I mentioned. Risk management, this is also becoming, this is probably already slightly more than some companies actually have chief risk officer whose job is to actually look at some of these problems in the company. Internal audit team. So audit team can probably look at all of these different parts of how to deter risks and provide feedback to the development team, testing team, all that. Process for improvement, process for important decisions. Make sure AI training or deployment decisions involve chief risk officer and other key stakeholders. When you make a system public, make sure that they are there is a process for it, right? You have the entire company getting to see it, or you probably also have beta testing that is done with some set of users without making the system public, and then only you make the system public. There are many examples that where we have seen systems that are made public, which have been taken down because probably a lot of these measures were not taken before making the system public. There was probably a decade ago, there was a Twitter chatbot that was made, TSAI, which started becoming, people started talking to it and then getting it to have views of certain topics over a period of time. Actually, over a period of less than 24 hours, this chatbot got trained into saying things that it should not say. And of course, there's recent examples of Gemini also. All of them, it could have been, some of these backlashes could have been stopped or reduced if more of internal auditing, more of internal testing, more of internal discussions would have happened before making the system public. Rogue AIs, right? So this example here is a common example used to show how this game was developed to participate in the race and win the game, win the race. But the boat decided to do certain things so that it could actually get rewards. And it learned this, that it was getting more and more rewards by just doing some things like this, going and hitting different boats and getting these points. And it started doing the same thing again and again instead of actually participating in the race and winning the game. This is definitely ways by which we see some of the systems do things which we don't anticipate it to do. And I will connect this to alignment problem that we discussed also, which is where we say that, look, system has to do A, but the system ends up doing something beyond A. And of course, we risk losing control over A's as they become more capable in this case, right? It's just not participating in the game. And if you think about it, this is also connected to some of the probably last decade or so, which many of us are trying to control, many of us are trying to understand a bit more, is also this mental health issues with people using more of this social media. And it's been studied very, very well. In this case, YouTube Insta user engagement is designed in a certain way that it was designed for us to get more and more personalized information, so we could actually consume content that is very relevant to us. But it ended up actually affecting mental health of people. Daily seeing my friends posting about their success stories, my schoolmates posting about a new car that they bought, or they're getting married, they're going on a vacation. All of that sometimes is actually going to be affecting users who are consuming that content. Of course, I took only certain examples, but there are many, many more examples in the context of how social media is affecting mental health, which is to some extent that could be connected to this rogue AIs, right? It was designed for something, these personalization, this user engagement, all that, but the effect that it is having is beyond what it is designed for. Power seeking. Right? These agents are going to start seeking more power as things move forward. Right? It can be instrumentally rational for AIs to engage in self-preservation. Loss of control over such systems could be hard to recover from. Right? When these systems are going to become rogue and do things whatever they want. Just imagine if a system like this, which is put in war, you ask it to do something, you ask it not to actually drop that bomb, and then it decides that, look, I will just drop the bomb. Right? So it can be dangerous for various situations. War is just one extreme example, but you could think of some AI system deployed at home for elderly people. It decides to do something versus what it is supposed to be doing. Deception, we'll see deception in a different context across the semester, but for now, deception, these technologies, these models can actually deceive people who are using the systems. Various researchers, such as money and computing power, can sometimes be instrumentally rational to seek. The model is are looking for it. AIs which can capably pursue goals may take intermediate steps to gain power and resources. Right? It can do that. Some solutions: AI should not be deployed in high-risk settings. Just now the example that I said, war. Such as by autonomously pursuing open-ended goals or overseeing critical infrastructure unless proven safe. Critical infrastructure, again, we saw it earlier in the class, which is power grids, all of these national important installation systems cannot be put into any risks, right? Need to advance AI safety research in the areas such as adversarial robustness, model honesty. This is just the last slide we spoke about. This is deception, transparency, and removing undesired capabilities. And that's where my particular interest is. Can we actually contribute into any of these topics to reduce the effects of these models? If you think about how much growth has happened, meaning particularly one metric called as GDP, if you look at it, in the last, so this is x-axis is the world GDP adjusted for inflation, and y-axis is the actual value. If you see in the last, let's take this would have been, let's say 2000 or something, only in the last 20 years or so, the GDP's growth is so high. Right? Took hundreds and thousands of years for Homo sapiens, agricultural revolution, and millennia for industrial revolution. Right? It took hundreds and hundreds of years. Now, centuries later, AI revolution is changing the derivative is actually getting more and more. The GDP is increasing because of these AI revolution. AI revolution, as in for now, but of course in the recent past, it could have been the whole software development industry, the IT industry, all of that. Acceleration is very high. So if you think about some of these technologies, I don't know how many of you have watched the movie Oppenheimer. If you think about it, that's a great example for dual use risks, right? Built it for something, but it ended up being used for something else. So dual use risk, double-edged sword of technology. One is getting built for something, but used for something else. A nuclear bomb accidentally fell out of a bomber over New Mexico in 1957. A B-47 bomber accidentally dropped a nuclear bomb over South Carolina. 1961, or South Carolina B-52 bomber broke up and 2 nuclear bombs fell to the ground. I think these are sort of say risks that have, errors, mistakes that happen, particularly in the context of nuclear weapons. Right, a big list is there. So last one, and at least in this list, is 6 nuclear-armed cruise missiles were mistakenly loaded onto B-54 bomber in North Dakota. There's, given that we have seen all of these risks, I would request you to think about some of the solutions that one can build. We have seen in different contexts for the taxonomy what all solutions can be built. It'll be nice for you also to think about them and share the solutions as we proceed in the course. Let me walk you through some abstract level of solutions that could be built. So solutions could be at the level of people, policy, and technology. And this is very, very abstract. If you think about, so to say, these audit metrics or standards that have been developed, they would use these terminologies: people, policy, and technology. Train people about these safety issues we already saw. Tell the developers about the issues. Policy, do not allow a company to do certain things. Technology, if the technology is made safe, do the testing, do reviews of the code, all of that. Make the technology open source so people can actually look at what the technology is doing. So people, policy, technology. Now let's take a look at, so that's the solution, right? So we saw what are the different types of risks. We saw some solutions for each of the taxonomy. First, we saw actually different types of risks. Then we saw a taxonomy to look at the risks. Then some solutions for each of the risks category. Now let's look at how to decompose risk. Again, this is slightly maybe abstract, but I will actually use some examples to show you how this could be done. Risk, that's what we want to measure. Vulnerability, hazard exposure, and hazard itself. Definition for these are: Vulnerability is nothing but a factor or a process that increases susceptibility to damaging effect of hazards. A factor or a process that increases the susceptibility to the damaging effects of the hazards. Again, we'll walk you through some examples which will make it clear. For now, it is the factor or the process. Exposure, extent to which elements are subjected to or exposed to hazards. Right? Elements being people, property, systems, all of that. Hazard, a source of danger with the potential to harm. Hazard itself, right? A danger that could be with the potential to harm, in the case, harm people, property, system, any of them. Okay, let's show you some examples also. Risk, this is a risk corresponding to a specific hazard, not the total risk. Particular, we are talking about only an hazard. Next few slides, you will see some examples of each of them. Then it will get clearer what each one of them are. Here, X denotes nonlinear interactions. Well, multiplication is basically nonlinear interactions, right? That's what it means here. Hazard is a shorthand for hazard probability or severity, which is what is the probability of occurrence of that particular hazard. Okay. Some examples to make it clear. Injury from falling on a wet floor. Right. Risk is the vulnerabilities, body brittleness, right? If you fall, if you are strong, the effect of falling may be lesser. Right? Hazard exposure is floor utilization. How much meaning when you're walking, is the entire floor wet or only some parts of the floor is wet? Exposure of the hazard. Hazard itself, how much the floor is slippery. Is it water because of which it is slippery less versus it is actually soap water because of which it is actually more slippery, or the floor itself is stone and therefore granite or marble or something like that, and therefore it's much more slippery than a normal cement floor. Right? So that's the way to think about it. Vulnerability, hazard exposure, and hazard. In this example, it is body brittleness, floor utilization, and floor slipperiness. Many you can address all of these three things by doing this, right? Brittleness, get more and more stronger. Floor utilization, put a signage saying that it is actually slippery, and to reduce the slipperiness, dry it as soon as possible. So these are risks. These are, so to say, how to address the risk or solutions for them. Another, I'll walk you through some quick examples, given that you may have understood what is going on in terms of measuring. One or two more examples quickly will help you get a better idea also. COVID, vulnerability, old age, poor health, comorbidities, all of that is vulnerability. Hazard exposure, contact with carriers, you're on a metro, you're on an aeroplane, all that. Hazard exposure in the aeroplane, hazard prevalence and severity. In the city that you live, the COVID numbers are very low, so the hazard is very low, but then the society that you're living, COVID numbers are high, your severity is much higher. How do you address old age, comorbidities, do vaccination, contact with carriers, safe distance, and prevalence and severity, clean places, do not touch, do not use your fingers, all of that. So the COVID and falling is generally at in our real world life. Let's look at actually the ML systems, right? ML systems, AI solutions. If you think about it, the hazard here reduce the probability and severity of inherent model hazards. right? So the solution could be thinking about, look, can I actually reduce the alignment problem, increase the alignment? If I increase the alignment, the hazard will be lesser, which is if I know that what the system is supposed to do, and that's what the system does, the alignment is much more aligned. The system and goals are well aligned to the human being's expectations, and therefore the hazard may be much lesser. Right? Agents would pursue good goals, right? They want to do certain things that they were supposed to do, they are asked to do. Right? So in this case, look, it is supposed to be doing this. It's supposed to be moving around, picking up a tablet, capsule for old age person that the robo is helping or the agent is helping. That's what it's supposed to be doing. It's not supposed to be going around and breaking things at home. Yeah. Disaster risk equation. Continuing the risk equation, if you look at vulnerability, which you could think of it in an ML system as robustness, right? Hazard in an ML system, to reduce hazard, we talked about alignment. Vulnerability, if you have the systems to be more robust, then the risk value is going to be lesser. Withstand hazards, which is if there's a mistake, if there is a problem because of the AI system that are developed, there are more hazards for it. If the systems are developed more robust, the hazard also will get reduced. Right? So it should withstand hazards. So it's seeing a danger symbol. It should try and see what it should do, and it should make choices to actually go to the goal. And is there a way to actually avoid the danger also, right? It should not be deciding to, because there is a danger, I will actually go do something that is I'm not supposed to be doing. So it should not be doing this. Its goal is to go from here to here, right? Or find a way to do something. I'll show you what all it is possible. I already gave you one solution, what it could do. But it should withstand hazards. Hazards are going to be always there in the systems. One is with respect to hazard exposure, how it can be reduced. It can be reduced by monitoring, identifying the hazard, keep looking for what are the mistakes that could happen, possible errors that could happen, and then use that to reduce it. Let's go back to the example of robo picking up the box of vegetable and putting it and misidentifying an engineer for his box, or a Tesla car going on a speed of 50 miles per hour and then deciding to take a break in 20 miles per hour. Or the dog example that we have seen, right? All of that, if there was a bit of more monitoring being done, the hazards could have been identified, the dog could have been identified, the human could have been identified better. Right, so this is the solution that I said, which is one of the ways it could do is it should just avoid all the hazards. This is an hazard. First, it should identify the hazard, and then it should go to the goal that it was set to do. Another way to think about this risk measurement is that can we actually build systemic safety measures as part of the development of these models itself, so the risks are reduced while developing these models itself. Right? So instead of looking at these as three different aspects, which is vulnerability, hazard exposure, and hazard, can we actually build some systemic safety? Again, this goes back to the research component that we said. This is more at the level of figuring out how to add safety while building these models itself. So this is, if you do this, it's going to generally reduce the risks. right? So removing hazards. So this is, it sees that it's an hazard, it can't go there. So can it actually find a way to, either agent finds a way to remove the hazards, or we as developers find a way to remove these hazards. So there's also this question sometimes people end up asking, is that, do we want to just estimate the risk, or do we want to actually reduce the risk also? Or do we want to estimate the risk and reduce the risk? We just said that this is how risk is measured. If you think about it this way, it can actually help reduce the risk also. So first identify the risk, prioritize the different risks that we have, respond to some of the risks that you have identified in terms of, let's take changing some things in the model, guard railing. All of these methods can be evolved or added to the solution that you're building, algorithm that you're building, systems that you're building, and then that will improve the system that you're building, and then assess it again. So if you follow this process iteratively, then the risk will get reduced. You measure the risk, then you do this at 1 or 2 times, or n number of times, whatever iterative process one decides to do, the risks may be reduced. I'm just going back to the example that we saw before in this section, which is about the robo confusing a man for a box of vegetables. And if you think about it now, you can think of how to actually measure the risk. You can actually think of how to mitigate the risk, measure the hazard, all of that. Right? So a robo confusing man for veggies. If you think about what is an hazard here, what is the hazard exposure, what is a vulnerability? Vulnerability is misclassifying veggies to humans. Hazard exposure is employees and robots around each other. That's the hazard exposure, man and robo being around each other. Hazard is injury or death. Right, so now that we know it, you can actually measure the risks or evaluate the risks, and depending on that, find methods through the iterative process, we can start reducing the risk also. That's one example that I said I'll show you, but please do the examples for Tesla, Waymo, the chat bot that we saw, which is Air Canada, cost chatbot saying things that was not in the policy. You should also do the Twitter. There's another chatbot also we saw, right? UK customer chatbot. All of this, think about how to actually measure the risk, decompose the risk, and put the values, put the ways in which you'll actually measure and mitigate the risk as response in the email mailing list again.